Hello, welcome to another stream. How about that? How about that? Bet you didn't expect that shit to happen in the new year. Happy New Year, everyone, by the way. The first stream of the year. How about that? How about that? Isn't that amazing? Hello, 9-year-old Andrew, Daft Maple, XBS4M as in Grim, Daft Maple yet again, and Rex, Nether Chops, What's and Blots. Hello, welcome. So today is Friday, and that means today, according to the schedule, we're doing a random one-off stream. Sorry, Moon, hello, welcome. Really glad to see him. Who Lab 7, welcome. Today, according to the schedule, is a one-off stream. John, hello. And that means today we are taking a random topic and we're streaming it for one stream. So, and the topic of today is a Bézier curve. I hope I pronounced his name correctly. His, her, I don't know what that is. Their name correctly. Right, so who heard about Bézier curves? Who knows what it is? You probably seen them before. You probably seen them before. Yeah, so this is how they look like, and they're used quite extensively in computer graphics, specifically in the vector editors. So if we open Inkscape, you can instantly check out Bézier curves by doing something like this, right? And there you go. Here is a Bézier curve. Yeah, you can just modify it like that. You can drag things around. Where's the handle? Yeah, here's the handle. And by manipulating these two handles, you can create a pretty smooth and interesting curves. Right, so it's actually pretty cool. And apparently, they are not that easy. They're not that difficult to code. Right. They're actually pretty fucking easy to code. And this is exactly what I want to try to do today. So, let's actually explore how you can code one. There is a pretty good illustration on how to implement Bézier curves. I think this picture actually illustrates it quite well. Right. So, where is my tablet? Oh, this curve. Yeah, that curve is a Bézier curve. So let me grab my tablet and I'm gonna just draw and show you how it goes. Right, so the implementation basically revolves around a simple operation called lerp. Who heard about lerp? So it's essentially a linear interpolation function. Hello, Ranak Mehtav. I hope I pronounced your name correctly. I'm not sure. So let me open my paint. So lerp, right, is a function. Oh my god, Wikipedia is actually pretty horrible at giving a definition of lerp. But I mean, it's just a linear interpolation. Essentially, in a lot of programming languages, lerp is a simple function, right? Let's actually define it like this. It's gonna be lerp, right? Which accepts three values. A, B, and I don't know how to call them. We can call them like P. I don't know. So I'm not a mathematician. So essentially, P is between 0 and 1. Right. P is between 0 and 1. And what this function does, it returns you a value, right? It returns you a value between A and B, depending on the value of P. So P essentially gives you a percentage, like percentage of the path between A and B, right? And then it just gives you a value. Right, so we'll need this mathematical operation to implement Bézier curves. So essentially how you do that, you have 4 points, right? So this is where the curve starts. This is the start of the curve. And this is going to be the end of the curve. Right. Then you add the points of these handles. Remember how in Inkscape we had 2 handles, right? We had 2 handles. Let me create another Bézier curve. Yeah, something like this. So, so here's the first handle. And here is the second one, but it's actually somewhere down below, which is difficult to grab for some reason. But yeah, there we go. Here's the second handle. So you have these two handles. Right. Another 2 points that we have here are the points of these handles. Right. Next, we draw the lines between all of these points. Let's actually put it like that. Okay. So then we have some sort of a value. We have a value p, right? As I already mentioned, the value is going to be between 0 and 1. And what we're essentially doing with that p, for each segment here, we are building a point. We are basically using lerp to map p on all of these segments, right? So that creates one point here, another point here, and another point here. So essentially, if we animate p, we'll animate the movement of these 3 points. That creates another 2 segments, right? Then we map p again on these 2 segments, somewhere like that, and we get another segment here, like this. Then we map that segment, that p on the segment again using the lerp operation, and we get a single point, right? So, and you do that continuously until you end up with a single point. Right, and then if you animate p from 0 to 1, the point will be following that exact curve. It will be following this exact curve, the Bézier curve. So, and by modifying, you know, these 2 handles, you modify the shape of the curve, and this is how it works. So this is how you can code it. It's actually pretty fucking straightforward and pretty fucking simple. And what's funny is that I never fucking implemented that. And that's exactly what I want to do. So yeah, you have 4 points, 3 segments, you create another 3 points, then 2 segments, then another 2 points, single segment, 1 point, and you just you know, animate that. So that last point just follows the curve, and you just need to draw it. So pretty goddamn straightforward. Not gonna fucking lie, mate. So let's implement it. Okay, so maybe I'm gonna just keep this thing here. Yeah. And again, this thing actually illustrates it quite well. I hope it's gonna be... Oh shit, we can even animate that, I think. Are we gonna, can we animate it? Yeah. Yeah, there we go. This is what I'm talking about. So you see, we're animating this P, and this is how it's gonna look like, essentially. You see? It's pretty easy. What's interesting is that you can actually have more segments here, and essentially, the more segments you have, the more degree of the Bézier curve you have. Usually in computer graphics, we don't use more than like 3 initial segments because there's like no point. There's no point in having more. But you can add more. Instead of 3 initial segments, you can have like 4, 5, and it just will take more time to calculate the actual point. In which language, though? Why does it matter? It doesn't matter. But we're gonna use C, and we're gonna use SDL. The language doesn't matter. It's just a math. Okay, it's just a math. The language doesn't matter. Okay. Let me pour a cup of tea. Does it sound interesting? Does the topic sound interesting? It does in fact sound interesting to me, and this is something I wanted to code for quite some time. But now I have an opportunity to do so. Alrighty. So I have a tea, and I'm not afraid to pour it in my cup. Not afraid to pour it. So I suppose the first thing we'll need to implement is the lerp operation. Right. And the lerp operation is actually super easy to implement. You just take B, subtract it from A, and multiply by P. Is this ASMR stream? No, this is a TSMR stream. It's not just ASMR stream. ASMR is for normies, so this is a TSMR stream. Alright, so let me put this thingy away and let's get ready, boys and girls. Let's get fucking ready, mate. So how are we gonna call the project? I think I'm gonna call it Bézier. So how do you spell Bézier? I keep forgetting how to spell it. Oh, and by the way, you can check out the example that I showed here. So they use GeoGebra. I don't know how to pronounce this thing, but yeah. So Bézier, right? And let's start. Let's start. All right, let's start Emacs. Main.c. So again, as I already mentioned, I'm gonna be using C, and to output graphics on the screen, I'm gonna be using SDL because I'm the most familiar with SDL. So it's just gonna be super quick for me to do. Here, Hots and Plots, welcome to the stream. We're doing Bézier curves. How about that? Does it sound something interesting? Hope it does sound like something interesting. All right, so let's actually start doing this entire stuff. Let's write hello world. So yeah, I'm gonna try to just implement this particular algorithm in C and with SDL visualization. Are you doing this for the game? No, I'm doing this for education because I wanted to do that for quite some time. I wanted to try to implement Bézier curves, but I never had an opportunity. And today is a random one-off stream. On Friday, we just try random topics, and that's why I'm doing that. So we're just learning things. We're here to get educated. Cheers for self-education. Because, as already explained, it's super easy to implement, and I don't understand why I haven't done that yet. So, yeah. So this is a hello world. I never looked into how Bézier curve works, but that animation already explains everything. Yeah, exactly. So if you look at the Wikipedia like page or something, I don't know, but like mathematical explanation of Bézier curves, this shit is fucking crazy. But show a person like a single animation, oh, okay, that's easy to implement. So yeah. This is like there's such a huge gap between visual explanation of Bézier curves and mathematical explanation. Mathematical is just fucking cryptic as hell, but visual is just, oh, that's how we do that. I can code that. So let's just fucking code that and see how it goes. All right. What's up out there? Hello. Day 1 of 2021. Nice one. Nice one. All right. So let's actually create a makefile and do our usual thing. Oh, wait a second. I forgot. We have snippets. Can your Vim do that? Can your Vim do that? I don't think so. No, I don't think so. So, and yeah, let's actually try to compile this entire stuff, and it seems to be compiling. I'm not using any command line arguments, so I'm gonna just straight up them, and let's continue. Snippet changed my life. Snippets cured my depression. Okay. So here's Hello World. We managed to compile Hello World successfully. Happy New Year, Carrot91, and welcome to the stream. Okay, so let's actually try to initialize SDL as usual. So let's actually write our usual SDL boilerplate, right? And what we're gonna have here: package config C flags. Have you heard about multiple cursors plugin for Vim? I've never heard about Vim. What is Vim? SDL2. Yeah, so this is what we'll have to do here. Package config C flags SDL2, and we also need the libs. We also need this. Have you tried SDL2? No, I never tried it. Hello, Zombie Show. So I should probably try it at some point. Yeah. Package config libs SDL2. So, and now if we try to compile all that, it in fact compiles. And let's write the usual SDL boilerplate. Where did everyone go? I banned everyone because they usually backseat me, so I banned everyone. SDL initial init video. I forgot how to do that. I think it's just init video, if I'm not mistaken. Oh yeah, this is how you do that. And after that, after you finished with everything, you do SDL quit. All right. So, and on top of that, SDL init can fail, so we have to have some sort of function that checks the result of SDL init. My favorite thing to do is just to do something like check SDL code, which accepts the code, and then if code is less than 0, we're gonna do printf, actually fprintf, because we need to print on the standard error, saying something SDL error, and then I'm gonna do SDL get error. There we go, and then we're gonna exit with 1, otherwise we're gonna just pass through the code, and this is how we're gonna do that, all of that. Yeah, it's very dumb, but it kind of helps to reduce this constant if checking, which is kind of annoying sometimes. All right. So SDL quit, as far as I know, doesn't really return anything, so it never fails. If I remember correctly, we can actually confirm that by trying to check its exit code, but it's not gonna work because it never fails. SDL quit never fails. Cheers. Now, so we need to create a window, right? We need to create a window. So let me grab rn SDL create window, right? Where is this function? Where's this magical function that creates a window? Here it is. We only need to provide the title, x, y, w, h, and the flags. Should be pretty straightforward. Let's quickly do that. So here's the window, and we're gonna put it here. So here's the window here. So what's gonna be the title? The title of the window, I suppose it's gonna be Bézier curves, right? Bézier curves. The position doesn't really matter that much, in my opinion. It could be just 0. And width and height. I think we're gonna have like fixed width and height. It's gonna be screen, width and height. Width, height. And we can define these things later, right? So, and speaking of the flags, I keep forgetting what flags mean. So yeah, the only thing I probably care about here is resizable, right? So the window has to be resizable, but again, create window can fail, and it is not a code, it's actually a pointer, so we need another checker that will check for the pointers. Right? So it's going to be actually like this. If pointer equal to null, we're gonna do fprintf, std error, sdl error, and it's gonna be sdl get error. Emacs, what the hell is wrong with you, Emacs? There we go, and then we're gonna exit with 1, and then we're gonna pass through the pointer that we got from the SDL. All right, so and after that we can do something like check SDL pointer, then this thing. And there we go. So this looks like Lisp. Yes, this code literally looks like Lisp. It's pretty cool. And it also includes the check-in. If it's impossible to create anything, it will automatically fail. We don't even have to worry about that. It's amazing. Trust me. It's absolutely fucking amazing. So we don't have a screen width and screen height. So let's create a screen width and screen height constants. Right here they are. This is not the correct height. There we go. So we only have a single unused variable, a window. Cool. After that, after we've got a window, we need to create a renderer that can render on that window. Right. So user include SDL2. Let's try to grab for something like SDL create renderer. Yep. So you provide the window, you provide the index, which usually -1, which is because it's an index of a driver or something like that. In -1 means like choose the best or like first supported driver or something. And also flags are essentially something for hardware acceleration and whatnot. We're gonna figure it out as we code, so it shouldn't be that difficult to do. All right, so here's that. Here's the constant renderer. And window, we already got the window. Index is going to be -1. And what's going to be the flags? So let's actually try to find out. Flags are supposed to be SDL renderer flags. Let's find their definitions. Here they are. And the only flag I care about is probably SDL renderer accelerated. So I'm going to just put it here. And yeah, after that we can just check SDL pointer. Right, and there we go. We managed to create a renderer. And let's try to recompile everything. First day coding Bézier curves. Yes, this is my first time coding Bézier curves. Please be gentle, chat. Have you seen Nano Emacs? No, I haven't seen it. Is that as like a small PPL Emacs? Is that the one Linus Torvalds uses? All right. So now we need to organize event loop. So we're gonna have like a Boolean point, a Boolean variable, which indicates whether it's time to quit or not. And while it is not quit, right? It is not quit. We're gonna be rolly polling all of the events from the event queue, right? From the event queue. So it's gonna be while SDL poll event like this, and we're gonna switch upon the event type, right? And then if we've got an event called SDL quit, we're gonna just set quit to 1, and this is how we're gonna quit. Cool, we managed to organize an event loop. All right, so if I try to run Bézier application, it created a window that doesn't even clean itself up. Absolutely fucking disgusting window, as you can see. But if I try to close it, it automatically closes. Isn't that amazing? Isn't that amazing? I think it's goddamn amazing. Okay, so but we need to clean the window up. So if I remember correctly, it's something like we have to set draw color something. Let me actually try to grab the function name from the SDL2. Grab rn SDL. Can I do things like draw color? Because I don't quite remember how that function is called. Set render draw color. Oh my god, I actually managed to do that. Set render draw color. Oh, by the way. Yeah. And of course, this entire thing can fail. So before trying to set any color, we need to check SDL code. Right, like after checking all of the color, we need to check SDL code, and just to ensure that nothing failed. So we're gonna put a renderer here, and the usual thing here is to set the color. So we're gonna just set the color to the black, right? These three things are going to be 0, and this thing is going to be essentially 255. But there is a like this kind of way of setting color is really inconvenient because SDL has a separate type called SDL color, right? And every time like you've got this type and you want to set that color, you have to like destructurize the entire structure color and do things like XR, XB, and so on and so forth. And to be fair, by itself, like storing this entire thing as a structure is not particularly convenient. Way of setting the code, yeah. And some time ago, when I was working on a genetic programming project, some time ago, so you can actually check it out here, I came up with actually pretty cool trick. So there's probably a playlist there, and yeah, there's also a couple of highlights made by Kolumbetka. I need to finish documentation for this project at some point. Yikes. Anyway, so I came up with a pretty cool thing. So GP visualization. So, okay, so you see I have colors as 32-bit integers. You see, here are the colors that I use, and they are just represented as 32-bit integers. And the interesting part is how I use them. So let me show you how I use them. I can probably find it here. So this is the background color, anything like color. Yeah, so I'm using them through a hex color macro. So now we need to find the definition of this hex color macro. Maybe it was in the H, but I'm not sure where it was. Yeah, there you go. Here it is. Here is the macro. Here is the macro. We can try to define it somewhere here. Right. So look at this. It takes 32-bit integer and expands to that. Basically, it expands to 4 values separated by comma. Think about it. It expands to 4 values separated by comma. So you can do something like this. Hex color 0x000000 ff, and there you go, and it will work. Even though set render draw color accepts like 5 arguments, you set only 2 because this thing expands to 4 arguments, right? And you can actually store colors as 32-bit integers, and it's extremely convenient. It also includes alpha and so on and so forth. It's just extremely fucking convenient way of doing that. And I was thinking whether it's an actually intended way of working with the colors in SDL, because it's just so fucking perfect. And if it's intended way, why there is no such macro in SDL? But at the same time, it's very hacky. But yeah, I kind of like it. And you can just use hex colors, and you can get these hex codes of the colors from the internet. You can generate some palettes on the internet and just use them directly, and it will just work. So if I try to compile that, it's going to make -b, and it is compiles. So, and if I, well, it's not enough actually. We have to clean the background. Nice. It's amazing hack. Like, I came up with it when I was in the bathroom. I think, unironically. So I came up with it off stream, and then I used it on stream. It's actually kind of interesting to me. It's kind of neat, not hacky. All right. So let me see. So set render draw, and after that we need to clean, right? We need to grep for clean, or SDL clean. I'm not sure if it's a clean or clear. I think it's a clear, but yeah, doesn't really matter. SDL render clear, that's what it's called. Yeah. So essentially, it should clean up the renderer with the corresponding color. The current rendering target with the drawing color. Yeah. So this is what it does, and this is exactly what I wanted to have here. Who needs IDEs if you have a grep? Am I right? So, and then I'm going to just provide the renderer, and of course, check SDL code. There we go. There we go. Good Duke, what's up? Welcome. How are you doing? Happy New fucking Year, mate. Happy New Year. Okay, seems to be compiling, and after that I have to use this SDL present or something. So I need to find this function in SDL2. Right, it's gonna be grep SDL present. Yeah, there we go. Here's the function I'm looking for. So basically it swaps the buffers, right? Because we use the usual double buffering, and render present swaps the buffer, but it's not called swap the buffer because the double buffering is abstracted away by SDL, because SDL provides just abstraction over different drivers, so-called drivers. It abstracts away such things as OpenGL, Direct3D, Metal, and just regular software rendering and whatnot. I heard there's also frame buffer driver or something like this, so I don't quite remember. But yeah, so this function is supposed to abstract away the double buffering, and yeah. So after we cleaned everything, we just need to look at this interesting thing. Swapping the buffers never fails. So it returns void, so it never fails. Doesn't really make much sense, but it is. So yeah, setting the color, cleaning the renderer can fail. Swapping the buffers can never fail. I know. Sure. Maybe it does make sense. I'm not a programmer. I know nothing about computers. Maybe that does in fact make sense. I don't really know how SDL is implemented. Anyway, so now if I try to run this thing, as you can see, the window is perfectly clean. And to demonstrate how the color works, we can just set something like 18 here and observe that we have a little bit of a reddish window. So you see it's a little bit reddish. So we can set the red component of the color quite easily. Yep, so yeah, it does work. It's pretty cool. It's pretty cool technique, and yeah, feel free to use it. It's not copyrighted or anything, so you can use it. Yeah, so and at the same time you can also define constants, something like background color, right? Background color, and you can just define the black color. What is that? Are you debating me into something? I'm pretty sure you're debating me into something, L9. So let me first check how it looks like here. It's too bright in my opinion. I think it's too bright for a background. But we can probably use it at some point for something else. All right, and then you can just put the background here. Do you know how to inspect element and save it even after refreshing the page? No, I'm not a web developer. I know nothing about elements and stuff like that. I'm really sorry. So in university, they only taught us how to use SDL. And to be fair, I kind of missed the web development course, so I know nothing about that. I'm sorry. And I'm too poor to take another course on web development, so I'm kind of stuck with this language and this stack of technologies. Sorry, Stro. It is what it is. The life is hard, you know. Only rich people can afford a lot of education. Okay. Okay. So what else do we have? What else? We need to implement lerp, but we need to start like rendering things in shit. I think we need to start rendering. Specifically, we need to start rendering the lines. We need to start rendering the lines. Does anyone remember how to render lines in SDL? So we're gonna do grep rn SDL. SDL line 69 raiders from RW Grim. My god, thank you so much for the raid, RW Grim, and welcome to our epic Bézier curve club. That's right, what we're doing today, we're trying to learn how to code Bézier curves like these ones, right? So here's a pretty cool you know, visualization on how you can draw them, and what I'm trying to do right now is to draw them using C and SDL2. About that. And also check out RW Grimm at Twitch channel. He's one of the developers of Pigeon, you know, instant messaging client. So it's actually pretty cool. Welcome. Actual open source developer. Oh my god. Isn't that amazing? I think it's goddamn amazing. All right. So yeah, how I was trying to understand how I can draw the lines, right? So here are the functions that potentially draw the lines, and yeah, here it is. So essentially, we just need to draw a line from this point to that point. But on top of that, I think I want to use floating points. Where is the repo for this project? I haven't created one. You think it's time to create it? Well, let's create it. Why not? That's actually a good point. So yeah, I was in the middle of, you know, doing the boilerplate stuff. So let's create it. First, we need to git ignore Bézier executable, and also we probably need to add the license. Okay, MIT license. You see, I'm open source developer myself. I'm using open source licenses. How about that? I'm somewhat of an open source developer myself. Okay. Wait a second. Can I have a snippet for this? Let's create a snippet for this thing. Okay, yes, new snippet. Name MIT, key MIT, cool, and then I'm gonna put this thing here. And how can I get a year automatically? Okay, I know that the copyright holder is this dude. I don't really know who that is, but he's like, you know, holds all of the copyrights of my work for some reason. I don't know why. So Emacs Lisp get current year. So how can I get a current year in Emacs Lisp? Parse time date to time. Okay, there's a function called date to time. Date to time. No, this is not really good. Format string. Time of day. I just need examples. Format time string. Oh, well, you also Googled it up, I see. I can Google things myself too. Eval, I think it's eval string, or is it string eval? String eval. I forgot how to do that. Like, you can evaluate, let's actually go to Scratch buffer, and then I can try to do something like this, right? So it gives me that, and the thing we need to do here, we need to insert it somehow. Yeah, snippet, Emacs Lisp code. Writing snippets. Okay, show me an example. Okay, so this looks like this. All right. So you do something like this when snippet. Okay. Do I just wrap them in backticks? I think I just wrap it in backticks. Okay, so I just remove that and I wrap this in backticks, and that should actually work, hopefully. And it's going to be called MIT, and create a fundamental mode and whatnot. And I think that should be it, boys and girls. I think that should be it. So essentially I can do reload all, and then I can go to here to fundamental mode. Reload everything. Thank you very much. And then if I try to do something like boom, look at that, it fucking worked. So we have a snippet with the license, which actually updates like automatically, so I don't have to update that snippet because it evaluates a year every time. Right, so I don't, like, the next year I won't have to go back to that snippet and update it, because it just, you know, gets the current year from the computer, which is actually pretty convenient. So I can do things like that. MIT, copyright, year, Alexei Kutepov, I have no idea who that dude. And yeah, this is pretty cool. Can your Vim do that? All right. So that's pretty cool. So for those who wants to know more about this kind of magic, it's called Snippet, which is extension for Emacs, and it's pretty fucking magical. Not gonna lie. So yeah. So you can find it somewhere here. And I didn't even star it. The fuck? I'm gonna give it a star. I think it deserves a star, even though it has 2,000 stars, and I don't have a project with 2,000 stars. No, I'm gonna take it back. I'm actually jealous of these many stars. So anyway, I'm sorry. I think I had too much tea today, so let's continue. Okay, readme MD. Bézier, this is not how you spell Bézier curve, so the first one has to be like this. Bézier curve. Le Bézier curves or something like that, probably like that. Okay. Quick start, and what you do here is just console, then make, then Bézier, and like this. Can I tell the matching room here if you're gonna marry some beautiful girl and gonna get her surname as yours? Probably. I don't know. So it will need to make like a database request to the marriage database of the government or something every time I'm trying to generate a license. I have no idea. Alright, so quick start. Quick start is done, and what we're doing here, we also have a bunch of references, and as a reference I'm gonna use this thing here. So here is the reference. We're trying to be scientific here, right? We're trying to be scientific. We provide the references. If we use some materials here they are. That's what we used. And probably also Wikipedia article. Also, like, I heard about like the way of drawing Bézier curves in the past, but I cannot remember the references, so this is basically off the top of my head. Just a fun little project to learn how to render Bézier curves. There we go. So I'm also trying to spell it correctly. Hopefully I'm spelling it correctly. Okay, so and then I'm gonna git init this entire stuff, and let's see if we can do a committee, and then maybe even pushy. How about that? Ready, set, go. Okay, we need to go and create the repo for this thing. So, new. Bézier. Just a fun little project to learn how to render Bézier curves. It's gonna be public. I said it's gonna be public. Then we're gonna create the repo, and there we go. Nice websites, GitHub. Okay, so let's do the following thing. Add origin, this thing, default push, and chat. I'm pushing. Boom. Cool. So now you can find all of the source codes right here, right now, right here, right now. Let's actually update the project command. So update cmd project coding Bézier curves. All right. So and source code https github.com/Bézier. Go. Cool. Who needs copy paste when you can just type out the whole URL from your head? All right. So let's go back and start working on this stuff. Right. As I already said, I want to be able to render the lines, right? I want to be able to render the lines, but I don't really like the interface of this function, right? It accepts the renderer, then it accepts the integers, and like it accepts separate components of the integers. What the hell is this? Excuse me, what the hell is this? And also it doesn't even accept the color of the thing I'm trying to render. This is absolutely disgusting, mate. Hello Devwarak, thank you, and happy 2021 to you as well. All right, so I want to have a better function. First of all, I want to have a vector too, which accepts, which actually stores floats instead of integers, because I'm going to do floating point arithmetics. Right, and I want to have something like render line, which obviously accepts the renderer. There is no way around it. It accepts a renderer, and it accepts the begin and the end, and also the caller. But it's going to accept the caller as 32-bit integer. Guess why? Actually, I think the definition of SDL caller also 32-bit integer, isn't it? I think it is. Yeah, I'm gonna accept it like that. All right. So, and we just need to implement that. I think it's gonna be a little bit more convenient. So we're gonna start with SDL set render color. We do the renderer and we do hex color color, and then we check SDL code, because this entire thing returns a code. And now we need to call the draw line, right? External, remove that. And of course this thing can fail, so let's check the exit code like this. So here's the render, right? But now we need to do these things. So we'll have to do well, this is begin. First of all, we don't need second arguments here, and this is going to be just two ends. But they are floats, not integers. So one of the things we'll have to do here is floor them, right? We're gonna floor them. Happy New Year to you too, combi. Almost matches background color, so close as a floating head effect. I guess, maybe. So we're gonna do it like that, and we're gonna do it like that. And then I'm gonna cast everything to an integer, so hopefully that will work well. So, and this is why I wanted to create like a separate function for that, because this is the interface I need, and this is how much code I need to write just to render a single line with a particular color. I think it's kind of meh. It's like I don't really like that, so that's why I just wrap it around. And also I don't want to do any checks, because I want the application just crash if it cannot render a particular line, because it's not like it's a throwaway application, right? So we don't need to handle things properly. So if something goes wrong, just crash. Who cares? Okay, so the next thing, I want to render the whole thing. So we're going to render line. So we provide the renderer. And what's going to be the beginning? Okay, so I need a constructor for the vector. I definitely need a constructor, so it's going to be vec2, float x, float y, and this is going to be essentially just doing this thing, vec2, x and y, so it's a little bit easier for us to work with. So we're going to start rendering this thing with vec2, 0, 0, and the end is going to be, let me think, we can use screen width and screen height. I just want to test if this is gonna work, right? If this is gonna work. Okay. And now I need to provide the color. So what's gonna be the color? So what's gonna be the color? What's gonna be the color? We're gonna use maybe this thing. Unfortunately, I don't see how to grab the hex color from the thing here. It's kind of strange how it's just like literally impossible in my paint to do that. Okay, so we can just grab the color from GP as well. So I'm gonna go here. So what's going on in the chat, by the way? Is everything okay? Is everything okay? Do we need to ban anyone? Somebody's begging for attention. Alright, so what do we have? I'm gonna probably use the same palette. I'm probably gonna use the same palette. So we're gonna have a background here. So here is the background. So this is the grid color. Agents, maybe we're gonna use the red color of the agents for the line color. Right, so line color, so here is the line color. Alright, so and if I try to render all of that, let's see what's gonna happen. Let's see what's gonna happen. Cool. Did I miss anything? So what's going on? This is C. I keep forgetting that in C you cannot do this kind of stuff, so we have to do type def. There we go, and now you have undefined reference to symbol floor. Because on Linux, mathematical library is a separate library, so you have to link with it separately. Classic, fucking classic. There we go. So, and now if I try to look at it, here you go. Here we go. So here is the line. Isn't that amazing? I think it's goddamn amazing. You can barely see it, but it's there. It's fucking there. I wish we could like have thicker lines. But yeah. And also I want the size of the canvas to sort of scale according to the size of the window. To do that, we need to set the logical size of the device, the thing that we do in all of our SDL projects, right? If you never knew about it, I also didn't know about it, but there is a pretty cool trick. Where you can use logical size. I forgot where it is. I'll probably need to go to one of my previous projects. Right, go to the main and find logic. Yeah, there we go. So this is the function that we're looking for. We can take a look at the documentation for this function. User include SDL. It's defined somewhere here. Grep rn this, boom. Where it is? Where is it? Here it is. So set device independent resolution for rendering, right? So you basically lock the size of the canvas on which you're drawing to that specific size, and no matter how you change the size of the window, that canvas is gonna stay the same, and you don't have to worry about the size of the window, so you become independent from the size of the window. Alright, so, and now let's actually initialize that after we created the renderer, right? And of course, it's gonna be check SDL code, and this is gonna be the renderer, screen width, screen height, and I think that's it. I think we don't need anything else. Just recompile, mate. There we go. Look at that. No matter how I change this stuff, it stays kind of the same. To make it like more visible, I think we need the second line. Right, where's the second line? I'm gonna just copy paste this entire stuff. And in terms of X, this is gonna be screen width, but height is gonna be 0. Right, in terms of that, it's gonna be that. And I think that's going to be the second diagonal thing. Maybe I'm going to also run it from here. And here is the cross. And you see, I change the size of the window, the cross stays the same. So it's pretty goddamn convenient, isn't it? I think it's pretty goddamn convenient to work with this kind of stuff. Cool. So, but rendering just lines is not enough. I want to be able to also render rectangles. I think rendering rectangles is going to be extremely useful. So actually not rendering rectangles, but filling rectangles, fill rect, right? So I want to be able to define like the position of the left top corner and maybe the size of the rectangle, and it will just fill it with a particular color. So let's quickly do that. So it's going to be SDL renderer. Fill rect. Very funny joke, chat. So here's going to be the position, and this is going to be the size. So we're going to use size as a vector as well. And yep, so we need to set the color. So this is how we're going to set it. Yep, so we're setting it here. And instead of render draw line, we have to use render fill rect. I think this is what we have to do, but I want to actually search for this thing first. It's going to be remember SDL render fill rect. Chat. Do you feel rect? Yeah. So, and it accepts this interesting thing. It accepts a structure rect, and rect basically stores 4 integers. And before we can even fill the rect, we'll have to initialize that structure first and pass it. So that's how convenient SDL API is. Which is kind of brings a question: why am I still working with SDL? Because we have such things as raylib. Has anyone heard about raylib? I'm not Russian, but work with Russians. Ukrainian is more practical to do. Sure. So I always wanted to check out raylib at some point because it feels like a more modern SDL and more powerful SDL, and also it supports shit ton of different stuff. It has shit ton of bindings and stuff. So maybe at some point we're gonna try raylib because I kind of want to move away from SDL because SDL is kind of limiting in what it can do. So yeah. Anyway, but it's not today. It's not going to be today. Today we're using SDL. All right. So I need to initialize SDL rect. So this is how it's going to be done. And it's going to be position X, position Y, and instead of position, we're going to have sizes here. So this is the size. And on top of that, it's kind of similar to how we render the line. It's going to be just florf. This is going to be just that. And like this, int, boom. And then we're gonna just provide the pointer to the rect. And on top of that, I don't think we need to modify it, so we're gonna keep it unmodifiable. And this thing can fail, so we're gonna check if it didn't fail. So you see, to render a single rectangle, this is how much pain you need to induce on yourself. I don't speak English. And I also need tea. All right. So let me try to recompile that. And does that work? Does that work? It doesn't even compile because we don't have a hex color because we don't provide the color. Okay, I forgot to that we also need to accept the color. Right. We also need to accept the color of the rectangle, and we're almost there. ISOC forbids nested functions. That's very interesting. You forgot equals, and C already thinks it's a function. Cool. And now it works. Isn't that amazing? I think it's goddamn amazing, mate. So we also need like a rectangle colors. So let's actually grab something. So what we can use for the rectangle stuff. This is a visual C. I need a visual H where we have all of the colors. Where is it? So there's a wall color, foot color. Let's actually use this one. I think this one is going to be cool. It's going to be a rect color. Cool. And let's see what we're going to have. Fill rect renderer. So the position is going to be 0, 0, 0, 0. The size of this entire thing is going to be, I think, like 100 by 100. I think it's a good size. And then we're going to just use the rect color. It doesn't compile because it's a vect2. It's a vect2. There we go. So we have a convenient functions to render rectangles, to render lines, and stuff like that. So everything is pretty convenient. So we're going to use all of that to visualize things. Hopefully, hopefully we're going to use that to visualize things. But it would be nice to have like several lines. Several lines, well, thicker lines. That's what I'm trying to say, thicker lines. But you can't really have them. But maybe we don't need them, actually. Maybe we don't need them. Yeah, we'll see. We'll see. SDLGFX. Nah, I don't want to use it. SDLGFX. So let's do a committee. Add convenient rendering utilities, and let's push them right into the repo. So you can find the source code here. Yeah, well, somebody already did the command. So yeah. Does anyone have any questions? Because I kind of want to make a small break. So, and I ran out of tea as well, so I'll have to do something about that. I also forgot to bring a bowl where I can put the disposed tea. But, yeah. Small. Yes. Very small. PPL. What is your attitude to alcohol? I don't drink it. Is this fun for you to get drunk? No, it is not fun for me. But I'm okay with people drinking alcohol. I have nothing against that. Unless they try to actually rope me into drinking alcohol. Yeah. So I personally don't drink alcohol. I'm fine with other people drinking alcohol as long as they don't try to rope me into drinking alcohol. So that's basically it. Does it make sense? Yeah. The problem is that alcohol kind of messes up my brain, and I become extremely depressed when I'm drunk. So yeah, that's why I don't drink. It's not like I have some sort of health concern. No, it's just I just don't experience any fun when I'm drunk. It's just like, yeah, it's not fun for me. All right. So as I already mentioned, the idea of Bézier curves revolves around a simple operation called linear interpolation, or LIRP, right? And we need to be able to linearly interpolate between not only like specific values, but also between the vectors, right? Also between the vectors. So let's implement two different kinds of LIRP operation. So we're gonna have something like LIRP F, LIRP. Yes, LIRP. That's what we're gonna have here. We're gonna have LIRP. So it's gonna be AB, right? So the value is gonna be between these two things, and the percentage is gonna be P. So we're gonna do B minus A multiplied by P, and that's the whole thing. This is the whole LIRP, believe it or not. I think this is the whole LIRP, is it not? Oh no, it's not the whole LIRP. This is the whole LIRP, right? Because when you do B minus A, what you find is the distance between A and B, right? And then you take a percentage of that distance and you add it back to A, and this is LIRP, right? This is essentially LIRP. Cool. But again, according to the visualization here, we need to be able to do interpolation in the 2D space. So this thing only works in a 1D space. So let's implement a function that works with vectors, right? So it's going to be vec2, and it's going to be LIRP v2, I think. So by analogy with LIRP, so it's float, and here is vector 2. So in here we're going to accept A, B. What is going on, Belgian? Are you okay? So I'm not sure. Doom died? Oh, you mean the game or something? I don't understand. I'm sorry. Okay. So again, we could have implemented it like this, right? But we're programming in C. MF Doom. Oh, I don't listen to music, so I didn't know that. But it's actually kind of sad, I suppose. But yeah. All right. So we could try to do something like this, but we're in C, so we cannot overload mathematical operations. So what we'll have to do, we'll have to implement these mathematical operations for vectors. So we need a vector subtract, a vector scale, and vector add. So these are the operations we'll need. So vec2 sub, right? vec2 subtract. So it accepts vec2a, vec2b. So this is one thing. We can probably implement it right away. Well, actually, sounds pretty straightforward. bx ay minus by. So that's pretty much it. So the next one is going to be vec2 scale, right? So you accept A and you accept the scalar, right? And this is essentially what we're doing here. We accept a single scalar, and we are doing the following thing: x multiplied by s, b ay multiplied by s. There we go. So, and we need to implement add, which is kind of similar to sub, except it is called differently and uses different operation. Instead of minus, it uses plus. Pretty straightforward, not gonna lie. So what we're doing here, we're doing here vec2 sub, so we're subtracting a from b. Then we're scaling the result to p, so we're doing vec2 scale, right, so we're scaling it, and then we're adding it back to a, so vec2 add a, like this. There we go. So essentially, like, it's the same thing as in the previous lerp, like in the lerp. Where's the lerp? Yeah, here it is. So it's pretty much the same thing. If I put it here. But since we're in C, we cannot just overload the separations. We have to explicitly like write them like this. So now we have not only lerp, but also lerp v2. And I guess. Yeah, I think that's the lerp v2, and we'll have to do something about that. All right, so I want to kind of test lerp v2, and I want to define 2 points, right? I want to define 2 points, begin and end, right? Vec2 begin. It's going to be constant. You're not supposed to modify these points. It's going to be vec2. Let's actually define 2 points from the top left corner to the bottom down corner, like this, right? So this is going to be begin, and this one is going to be end, which is screen width and screen height. And the thing that is not going to be constant is going to be this p thingy, which you will be allowed to modify. And maybe we're going to just handle some sort of keys here, which will enable you with increasing and decreasing p. And we're going to calculate the point between these 2 begins and ends. Between these 2 begins and ends. And I want to be able to easily draw like a pretty fat, thick point, like a rectangle at a particular position without doing any like rectangular related stuff, without calculating its size and anything. Let's implement a function called render marker, right? So it accepts the renderer, renderer, the position of the marker and the color of the marker. So essentially it's going to draw a rectangle with the center at this position and with the predefined size, so we don't need to think about rectangular dimensions or anything like that, because sometimes we just want to slap a marker on the screen and just forget about it. I think it's going to be extremely convenient. So what we need to do, we need to know the size of the marker, marker size, right? So something predefined. So what is it going to be? I think it's going to be like 100. I think that should be enough. And then what do? We fill a rectangle with the renderer, right? The position is gonna be a position, but we're gonna subtract half of the marker. So essentially we can do vec2 marker size, but scaled, vector scale down, so scaled down in half. Right, so this is going to be the position, and the size is going to be marker size. There we go. So, and then we also have to specify the color, of course. We have to specify the color. So this is how we calculate that. This is how we calculate the position, and so on and so forth. I think, like, I see this kind of pattern quite often when you want to create like a 2-dimensional vector from a single value. I think we need to extract it to some sort of a function. What do you guys think? How would be such function called? So we call it vec2. What about vec1? Is that a good name of the function? So yeah, I want to have something like this. Does anyone know how such function would be called? Let's call it vec1. Why not? Brilliant. Yeah. I know. And essentially what we can do here instead is vec1 marker size, right? And yeah, we might as well Vec2 size. Yeah, Vec1 returns Vec2 is not that great. We can do the following thing where we could have like Vec2 size, Vec2 marker size, and this is essentially going to be just size, which actually simplifies it even further. Hello, Raul Rita, thank you, and Happy New Year to you too. Happy New Year to you too. So Vec1, yeah, it's kind of dumb, something like that. Yeah, so we're gonna do it like this, right? So essentially you just want to slap a marker there, you take the position, you take the size of the marker, you scale it, you divide it by half and subtract it from the position, and the size is gonna be the full size, and there you go. So, and now you have a pretty convenient function, just, you know, slaps a marker with a particular color without you worrying about anything. So, which is particularly convenient in my opinion. Okay, so we have that. I'm gonna remove all of this stuff, and now we have a begin and end, right? So it's gonna be render marker with the renderer, of course, at the begin, and where do we have? So this is gonna be a line caller. So this is begin and this is end. Cool. This is begin and this is end, and we have some problems here. Implicit declaration of Vec2. Okay, so Vec2 defined somewhere where it shouldn't be defined. It's defined, yeah, it's defined after it's used, which is kind of bad in C, and makes me question, why am I still using this language? Right? Why are we still using this language in 2020, where you have to worry about the order of declarations and definitions? I mean, come on. But Zozin, just use Rust! Yes, sure, that's exactly what I'm gonna do in 5 minutes, don't worry about it. Cool, so here are two markers, which is kind of... Yeah, so it's actually half of the markers, if you think about it. It's a half of the markers. And now, what I want to do, I also want to render a marker the following way. Right. So lerp v2 accepts, look at that, begin and end. So it accepts begin and it accepts the end, and also accepts the percentage. Right, it accepts the percentage. So for now I can probably put it at 0, right? I can put it at 0. What's up, Potato passing by? Welcome to the stream. And so what do we have here? We have a rect caller, right? Let's put it as a rect caller. Rect caller. Okay. So let's also start this entire thing like this. There we go. So here is the middle point, right? You cannot even see the begin marker. Now, if I make the percentage 50, you're gonna see 3 points, right? Here's the 3 points. So this is the begin, this is the middle, and this is end. So by basically setting 0.5 here, I say that point should be 50% the way to the end. So yeah, essentially we're interpolating. So if I put something like 75, right, it's going to be closer to the end, right? And what's interesting is that you can orient these points however you want, and the point is going to be just moving there. So this is basically the lerp operation. It's not that difficult to implement it without extracting away the separation. Abstracting away the separation is just once you have the separation, actually a lot of stuff is so easy to describe in it in terms of this thing. Alright, so what I want to do here, I want to actually put the marker size somewhere here, so we have a screen height and so on and so forth. And I want to make it slightly smaller. I think 50 pixels should be okay. Alright, and let's animate the p value, right? So we're gonna have something like p, right? And we need to count the time, right? So we need to start working with the time. How can we start working with the time? To work with the time, we need to know FPS and stuff like that. So let's actually introduce something like screen FPS, and we're gonna work with 60 FPS. So I'm not going to try to do anything fancy with FPSs, with maintaining FPS. I'm going to just, you know, calculate the delay and just wait for this amount of at the end of the frame. So it's not going to be accurate, but I'm not striving for accuracy here anyway. Anyway, so what I need to do to know the delay in seconds, right? To know the delay in seconds, I need to take 1 second and divide it by the FPS, and here is the delay in second, like delay sec, right? Delay in seconds, and what's interesting is that as far as I know, SDL delay accepts milliseconds, so we'll have to be a little bit careful with this kind of stuff. Yeah, it accepts milliseconds and also an integer, so we can try to do something about that. So delay ms, so, and we need both, by the way. We need a delay in milliseconds for the delay function, and we need delay in seconds floating point for mathematical operations, right? So we need both of them. It's quite important. So what do? I take delay in a second, right? And I multiply it by 1000 because, you know, 1 second is 1000 milliseconds. And then I'm going to florf this entire thing. I'm florfing this entire thing and convert it to integer. They use uint32. So I'm going to put it like that. So this is going to be delay in milliseconds. Hopefully the compiler is smart enough to maybe calculate all of that at compile time, so we don't have to calculate it at runtime, but yeah. Thrash 5, have you exercised this year? Welcome, how are you doing? So, and somewhere here, we're gonna do SDL delay in milliseconds. No, I haven't. Too bad, you're going to be bad. So I think I'm gonna rename delay in not delay, but delta time. I think it's a better name here. Query replace delay delta time sec, boom, and delay ms is going to be delta time ms, Oh boy, I'm not a very smart person. Delta time ms, boom, cool. So, and I also want to compute the time. So as we render those frames, I'm going to have like a global timer. And every time we render a frame, I'm going to do t plus delta time in seconds, right? And instead of p, what we're going to do here, we're going to use sine of the time. So what's the problem with the sine? Sine can actually be negative, right? Sine can be actually negative, and that's kind of the problem. So if we add, so it goes from -1 to 1 constantly, -1 to 1. We can add 1 to it, which makes it go from 0 to 2, right? From 0 to 2. And to combat that, we'll have to divide it by 2, right? Like this. There we go. So now we have a function that goes from 0 to 1. And this is exactly what we want, because the lerp only accepts from 0 to 1. And what's going to happen if we try to compile it? It's not going to compile because I'm Bebega. There we go. And as you can see, now we are animating, the movement of this thing between 2 points. Right, we're animating that stuff. And what's funny is that, again, you can orient these points however you want. They don't necessarily have to be here. It could be something like 100, 100, and another one could be, 250 and maybe 400, something like that, right? And if I try to show that, now it's animating between these 2 points, right? It's just animating between these 2 points. Yeah, it's pretty cool. So this is a lerp. This is how it works. You can interpolate between like 2 points, and this is exactly the operation that we're going to be using. Okay, so what else do I need? I think I still want to make the markers slightly smaller because they're too fucking big for my screen. Yeah, I think something like this. Maybe even let's do 50. Let's do 50. I think that's cool. That's a cool. Nice. So what if we have several points, chat? Have you thought about that? What if we had several points? Let's introduce an array of points. So back to, we're gonna call them PS. So, and we're gonna have also PS capacity. So basically the capacity of this array, amount of points that we can store. PS capacity is gonna be, let's say, 256 points should be enough for everyone. Happy New Year, everyone! Happy New Year. That's right, that's right. So we're gonna also have PS count, right? PS count, and interestingly enough, what I wanna do is I wanna get rid of this begin and end, and I get rid of this stuff, right? So now what I want to do, I want to iterate the points, starting from 0 up until PS count -1. So, and I want to, actually, if I need to render the points, right, if I just want to render the points, I need to iterate them like that. So it's going to be render, render marker, renderer, and what's next? The position, so it's going to be PSI, and the color is going to be line marker, a line color. So yep. Now here's the thing, so right now we don't have any points. If I try to render this thing, it doesn't show anything, so we need a way to put points on the screen. So let's actually write some code for handling, so something like SDL mouse button down, right? So something like this. I think that's the event I care about. Let's see what we can get there. Looks like C++. Looks like yo mom. I'm sorry. Yeah, it's actually C. It's actually C. Mouse button event. So, and what we're caring about here is a mouse button, right? Switch event mouse, or is it a button? I think it's literally button. I forgot how to do that. Maybe just a mouse button. Okay, I'm gonna try to compile this shit and let the compiler tell me what the fuck I'm doing. Switch quantity, not an integer. You could have told me what it is then. Is it mouse button button? Oh yes, it is mouse button button. What the fuck? I mean, we could probably do something like this. Case SDL left button left, yes, SDL button button left, and in this case maybe we want to print something. Maybe we're gonna print something. I don't know, test. Let's put a test here. Cool. I need a cup of tea, chat. There we go. You see, I click with left thingy and it works. And you know what that means? That means we can add more buttons. We also know X and Y of where I clicked. So that means we can do PS count ++ vec2 event button X, and also event button Y. There we go. So now, isn't that amazing, chat? Look at that shit, bruh. So now we can put points on the screen. So the next thing I want to do after we render all of that, I want to render their interpolation, right? The way we render it, like the movement from one point to another one, right? So how we have to do all of that? We have to do PS count -1, right? And ++I. So we basically need to interpolate between PSI and PSI +1. PSI and psi plus 1. That's quite important. So it's going to be lerp v2 ps1 and ps1 plus 1, and we're going to use this synth thingy on the time plus 1 divided by 2, right? And that will create shed ton of interpolation points between all of the pairs of them, right? And the thing we need to do here, we need to render this goddamn marker, renderer. So this is the marker that we're trying to render here, and the color is going to be, I don't know, what was that? A rect color. So this is going to be the rect color, and that should be it actually, I think, and it's segfaulted. Holy fuck, why did it segfault? Maybe because... Oh, that's really strange, because it shouldn't be segfaulting. Oh, wait. If it's 0, right, if it's 0... Yeah, I see. PS count greater than 0 and... Yeah. Now look, chat. I have 1 point, I have second point. And now, as you can see, the point is interpolating between them. What if I add another one? So yeah. Notice how there is one less point of green, right? So amount of greens is the amount of reds minus 1. There's one green missing, and that's kind of intentional. So what you have to do now, right, you have to do another step. You have to now interpolate between the greens as well. You see? You need to also interpolate between the greens. And then you have to interpolate it again and again and again until you end up with a single point, right? Until we end up with a single point, and that point is following the Bézier curve. You see what I mean? So that's the Bézier curve implementation. So, and yeah. And before we continue, I want to make a cup of tea, but I forgot to bring a bowl where I usually put the disposed tea leaves. So don't go anywhere, right? Or otherwise I'll come to your house and I'm gonna curve all of your Béziers. All right, just stay here. Don't go anywhere. Alright, does anyone have any questions, boys and girls? Does anyone have any questions while I'm making a cup of tea? Did Zozin ever had a room tour? No! Never. I'm here, I swear I didn't move. Well, it's too late! All of your Béziers are already curved. Well, you know, real Béziers have curves. Room tour... Do you really want to see a Soviet, like old Soviet apartment? Is that what you want to see? Okay, Google up. No fuckers, like babushka apartment? Because he did a video, yeah, Soviet apartment, like... So watch this video to get the gist of where I live, alright? So you don't need me to do any fucking tour, just watch this video, the Soviet babushka apartment, yeah. So that's pretty much what it is. Nothing special, right? Link? I can give a link, I suppose. Just a second. Can I? Yeah, I can copy paste it as. I didn't mean to save a link as. But okay. All right. So here's the video. Watch it. All right. So does anyone have any other questions? It's Earl Grey again, by the way. I went to the store today, and I'm gonna tell you, there's literally no one right now on the streets and in the store. Everyone is having a hangover right now. So yeah, the whole fucking country. Yeah. What is the best snack while coding? Your mom. I don't know. Like I don't usually snack while coding because I'm completely focused on coding. So I don't know. To be fair, I usually drink tea. Like yeah, that's what I usually do. Happy New Year to you too. Happy New Year to you too. I like chocolate. The sugar gives me a rush that helps me concentrate and also makes you fat. Bread makes you fat? Right. So, yeah. I think I need to now go to the kitchen and turn on the kettle. Right. As usual, don't go anywhere or my bot will detect your absence and fucking ban you. That's right. Don't go anywhere. Stay here. What's up? Chat, no, yeah, no fat shaming, no fat shaming. You're so fucking lucky, Annabeth. Holy shit, you won't believe how lucky you are. I get so easily fat, it's insane. Yeah. So, I think we need to commit all of that. They wouldn't call it being lucky, but okay. Oh, okay, so maybe I don't really know your situation, so I'm taking everything back. So, I'm sorry. Alright. Let me see. I think I want to commit all of that. Add first step of building the Bézier. I need to spell it properly. Bézier curve. So this is how we're supposed to spell it. Le Bézier. I don't know. I'm not gonna do that. Let's push that right into the repo. So I'm gonna yeah. So we can check out the source code of this thing here, and let's continue. So as already mentioned, we just have to go for the next step, right? We need to go for the next step. I kind of want to rename some of these things. So I remember the line was red color. So let's actually rename it to red color. So this is a red color, and rect was green color. Green color. Right, and we need another one. So something like wall color, I remember, was blue color. Define blue color. Okay, cool. So what we're gonna do here is can we do like the second step of Bézier curve building without an intermediate array? Can we do something like that? I wonder. Because I'm just doing these two things, but that means you'll have to It would be easy just to build the second one, but my brain actually refuses to think about it. So essentially you can, right? You kind of can. Oh, I see. So you will have to do it this way, right? Of course, PS has to be greater than 0, and I is PS count minus 1 plus I. PS count minus 1 plus I, okay. And essentially, like here, what we're doing, right, here what we're doing, we're looking 1 point in the future, right? We're looking 1 point in the future, but for the second phase, we'll have to keep looking 2 points in the future. So let's actually do something like this. Phase 1, then phase 2, and then phase 3. Phase 3. Phase 3. Yep. Oh, and that means that I have to do minus 2. Yeah. So here is what we're going to be doing, chat. Here's what we're going to be doing. So here's the first interpolation. Here's the first point of the interpolation is going to be A. All right. And the second one is going to be plus 1 plus 2. Plus 1 plus 2. So this is going to be the B one. And I can also want to probably mark it as const. Right, and then we're drawing interpolation between A and B by doing lerp v2, A and B. See? And this is the marker that we're going to be drawing. And interpolation is going to be actually the same. To be fair, like I'm using this value pretty much everywhere. I might as well introduce something like P, where I calculate this entire thing. Right, I'm calculating this entire thing like this. Synth, and I think, by the way, shut. My tea is ready, so I'll have to go to my kitchen yet again. So you know what that means. You have a perfect opportunity to get banned if you close the stream. So keep watching, even if I'm in the kitchen. Don't go anywhere, or otherwise you're gonna get banned. That's right. So, yeah. What's up? How was it good? Is everyone here? Okay. All right. So let's continue. So we have phase 1, phase 2. Well, phase 1 is just drawing the initial points, and phase 2 is just interpolating between them, and phase 3 is interpolating between interpolation, and so on and so forth. So, and we're going to be rendering the interpolation of interpolation. So it's going to be the next step in the interpolation. Okay, so it's going to be lerp v2, and we're going to use the blue color for the second phase of interpolation. Right. So let's see if it's going to work or not. And okay, and it's segfaulted. Nice. All right. So this means that PS count has to be greater than 1. All right. Look, here's the 1 point. Here's the second point. Right. And we have interpolation between 2 of them. And here is the third point. And you can already see how the blue one is following the Bézier curve. We basically implemented Bézier curve. We just need to like put a trail on the blue one, and there you go. Here's a Bézier curve. So, but you can actually have more of them, right? But for the next degree, you have to actually go more and more, because you also want to interpolate between the blue ones, right? You want to interpolate between the blue ones, but overall it's going to be like that. Yeah. So if you put like a circle of them, it's going to be actually pretty trippy, not gonna lie. Yeah, there we go. So yeah, that's basically what this is. It's just, yeah, this is what Bézier curves are. But of course, we're not going to stop there. We're going to try to implement them the way you usually work with them in Inkscape. Because in Inkscape, you just have something like this, where you just do these two things, right? And then you can do things like that, and you essentially have two handles, right, that you can manipulate. By the way, these curves are rendered the way I actually showed you, right? Essentially, right? Essentially, they're drawn like the way I actually showed you. Yeah. So we're eventually gonna actually have something like this. So the coolest thing about Bézier curves is that how simple they are, right? It's really fucking simple. And that's why I wanted to have it as a Friday topic, because I think it's interesting. I think it is, in fact, very, very interesting. So what's funny is that, can I generalize the amount of phases here? Is it even possible for me to generalize the amount of phases? Because what we do here, we're just decreasing them. We iterated by 3. Right, and then within that thing I have to have another generalization and so on and so forth. The apartment in the video is great, I'm not even joking, it really is. You guys are actually watching that video? That's I thought you're gonna ignore it, but yeah, I guess it's okay. Well, I mean, it's not impossible to live there, it's just like, it's kind of an old Soviet apartment, that's what it is. It is what it is. Nothing much to see here. Okay. So what's going to be the next step? The next step will be something like drawing like actual lines between them, probably. It would be actually kind of interesting. It's not that bad. There are way worse apartments here that costs way more. Okay, I see. Maybe I'm gonna do like a tour at some point, but I'm not sure. It requires a lot of preparation, and I also need to clean up my apartment. I just don't want to do that. So yeah. Right now I only need to clean up this part, right? Which is not even that clean anyway, so whatever. What's gonna be the next thing? I think I'm going to implement a pretty cool function, right? Since we know how all of that works, we need something like render Bézier markers. Yeah, this is how I wanna call it. So, and in the Bézier markers, I think we need yeah, I think we're gonna start with just 3 points. Yeah, I think we're gonna simply start with just 3 points. And we're gonna go along, right? We're gonna go along. So it's usually 3 points is enough for us, right? 3 points is enough. This is already pretty good. But 4 points would be even better. So let's continue. So it's going to be vec2a, vec2b, vec2c. And on top of that, I also want to accept some sort of a step. And then we can continue with all of that. All right. So what's going to be the step? So we're going to have p equal to 0 initially, right? And while p is less, you know, we can actually do 4. I think we can actually do 4 like this. We can actually do 4, and then it's going to be less or equal f plus s. There we go. Something like this. something like this. Refresh the page, refresh the page. Are we back? We probably lost a lot of people, but yeah. So what I'm trying to do here now is to actually draw the Bézier curve based on 3 points, right? Which is supposed to do actually based on 4, I think, but we're gonna start with 3 only, right? We're gonna start with 3 only. Okay, so, and how we're gonna do that? So we're gonna do lerp v2 from A to B by P, right? So another one is gonna be BC, and this gives me like B and C, right? And then we need to interpolate between AB and BC, right? It's gonna be vec2 ABC, and we're interpolating between AB, BC with the same interpolator, and ABC is essentially the point that you want to draw, right? It's essentially the point that you want to draw. And render marker, we also have to accept the renderer. We also have to accept the renderer. Still the renderer. Yeah, the counter didn't update because like every time something like that happens, like half of the people just instantly close the tab because they feel safe thinking that they're not gonna get banned for leaving the stream. So, but oh boy, they're wrong. Anyway, so yeah, now we just need to now we just need to render this thing, and it's gonna be let's render it with red color. Nah, let's go with green. Yeah, it's gonna be green. So that's the whole thing. That's the whole thing. It's kind of interesting. So let me see how we're gonna go about that. So this is the whole Bézier thingy. Now, so we're gonna get rid of these phases, right? We're gonna get rid of these phases. But I'm not really sure if I want to get rid of them because it was kind of cool. But maybe not. Whatever. Yeah, let's remove them because it was just to test things around. It was just to test things around. Okay, so we don't need this interpolator anymore. And essentially, I'm going to be iterating through all of the points here, but the count has to be greater than 1 because we're going to do by 3. We're gonna do by 3. PS count. First of all, PS count has to be greater or equal 3. I think that's gonna be a little bit better. Greater or equal 3, and I PS count minus 2, right? Plus I. Cool. And essentially, how we're gonna go about all of that? So it's gonna be 1, 2, 3. And yeah, I think I'm gonna actually do it in a very simple way. Render marker, renderer, PS0 is gonna be red color. Right, it's gonna be 1, 2. And then we're gonna do render Bézier markers. So it's gonna be renderer. PS0, PS1, PS2, right, PS2. And do we provide any color here? I think we should provide the color and also step. So what's going to be the step? I think the step could be something like 0, 1, right? And the color is going to be green color. Yeah, there we go. So, and here's going to be the color, uint32 color. And the green color is something like this. There we go. There we go. Okay, so something is... Yeah, that's really strange. Wait a second. The fuck? Why did it even try to... Ah, yeah, I see. Okay. Okay. Yeah, if PS count is greater or equal than 3, then we try to render this entire stuff. And we need to do size t less than PS count plus I. I'm gonna put it here somewhere. I'm gonna remove it like that. It's gonna be I, and there we go. There we go. And let us see. Okay, cool. Now, look. So here's a Bézier curve. And another thing I want to be able to do is to modify the positions of these points so we can actually control how it's going to look like. We can try to actually make the proper Bézier curve as it's done in Inkscape with actually 4 points. But that will make it a little bit more complicated. We'll have to accept A, B, C, and D, right? And then do several steps of this. We'll have to do A, B, B, C, C, D, then A, B, C, B, C, D, and then A, B, C, D, right? So, but it should be actually pretty straightforward. Let's actually try to do that. Right. So this is A, B, B, C, and we need to C, D, forcing a C, D, then A, B, C, and then another one, B, C, D, which is essentially like almost this. Like this. This one is gonna be B, C, C, D, and then vec2, A, B, C, D, lerp v2, A, B, C, B, C, D, P, and we are just doing A, B, C, D. There we go. So, but in this particular case, it has to be like 4 of them, and we're gonna use 4 points instead. Right, we're gonna use 4 points instead. Okay. Cool. So 1, 2, 3, 4. Cool. So what I'm thinking, we need a way to control these points. So I'll need to implement some sort of an interface that allows you to drag them around. So, and once we'll be able to drag them around, the curve will also update accordingly. By the way, we can actually add more points to the curve by reducing the step, right? By reducing the step. Let's see how it's gonna go. Boom, 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 boom. Yeah, there's more of this. And what's funny is that you can try to smooth it out by basically connecting the dots with lines. Why not? I think this is one of the things you can do. Yeah. Okay, before we're gonna go any further, I want to commit whatever we have and then start working on being able to control the positions of those points, right? To control the positions of those points. I think it's gonna be kind of cool. All right. Okay, so this is basically what we did here. Implement render Bézier Mercus, and I'm gonna push that right into the repo. So, and you can check out the source code of this project here if you're interested. If you want to learn something, I don't know, you want to steal the code, you want to sell it on the internet, whatever. It's under MIT. You can do whatever the fuck you want with it. Who am I to judge you? All right. Oh, by the way, we can even mark these things as const because we're not even modifying them, because this code is purely functional, immutable data structures, by the way. Immutable data structures. So yeah, and it's a bunch of lerp2. That's what it is. This code looks kind of scary, not gonna lie. But it also looks generalizable, I think. You can kind of generalize it, but yeah, I suppose. But I wonder if you can easily generalize it without using any how to say that? Any data structures for storing intermediate data. You probably can. You definitely can. It's just I'm too lazy to do that. So yeah. Okay. Let's implement like a general mechanism that lets us detect whether we clicked on a marker or not, right? Whether we clicked on a marker or not. Also, maybe we're gonna implement something that doesn't allow us to have more than 4 points for now. Yeah. Okay, let's do it like this. If PS count is less than 4, only then we're pushing yet another point here, right? Only then we're pushing yet another point. Let's recompile all of this, and if I try to add more of them, I cannot add them. As you can see, I cannot add them. Okay, cool. So now, but did you forget already that you should make class? Okay, yes, sure. PS at, right. So what we want to do here, we want to take a vec2 position and check if there is something at that particular position. What we can do in this particular case, we can try to return an index, right? We can try to return an index, and -1 is going to be indicating that we don't have any point at that particular position. No. All right, so how we're going to do all of this? We're going to be iterating the points. Right, we're going to be iterating the points starting from 1 to PS count. So something is wrong with my PS count variable, don't you think? So there's something definitely wrong with this name. I think I fucked it up. So let's actually unfuck it. And now, how do we know if a particular position is within a particular marker? Marker has a size. So, right, marker size, and it's defined somewhere here, right? It's defined somewhere here, and we can use it to detect all of that. So we need to know the beginning of the, yeah, so let's define it like this: const vec2 size, and it's going to be vec2 marker size, like this. There we go. So then we're going to have a position. Vec2 position is going to be size, vec2 scale, and we're going to do it by half. So this is the position essentially, right? So, and the, oh god damn it, this is the position of mouse, and this is the position of the point. So we want to actually prefix it. It's going to be PS position, and this could be something like PS size or whatever. Right, and that means this could be like PS, like this. Cool. So, and if position X is greater or equal than PS position X, and we actually need like ands, right? So this is the begin, like PS begin, that's what we can call it, right? So this is the begin, and then we also need the end, right? PS end, vec2 add. Have you ever swum in ice? Thank you for this question. So PS size that, and I also need to subtract the point position vec2 sub PS I. So yeah, we take the position, we subtract half of it, and now what we do, we take PS begin, and PS size. PS stands for points. So essentially it stands for points that you have on the screen, right? Because now we can put points to draw a Bézier curve, and PS is the array of these points. That's what it is. Makes sense? Hopefully that makes sense. Okay, so now we know the beginning, the ranges of the beginning and ranges of the end. So it's basically begin and end. So, and then we have pos x greater or equal to ps and x. And we need to repeat the same thing. We need to repeat the same thing, but with y's, right? But with y's. Right. And if this entire thing is true, we found the index, so we just return I, but we need to convert it to integer, of course. And if we didn't find anything, we have to return -1. So this is how we do that. We can take the position of the mouse and quite easily indicate, like find whether we're clicking on a particular marker or not clicking on a particular marker. I heard Russians swim in icy water. Well, not all of them. There's some weird people who do that. Okay. Cool. So now what I want to do. So if you have more than, like, equal to 4 or more than equal to 4, we're going to try to detect whether you are clicking at existing marker, right? Mouse pose. So we're gonna have something like that. It's gonna be mouse pose, vec2, mouse pose. Right. So we're gonna try to print this thing. PS at mouse pose. Okay. Oh shit. I fucked up something. How did I easily fuck it up? Like, I just copy paste this thing and now what? How did I easily fuck it up? Like, what did I even do? The fuck? That was strange. I just straight up. Okay, and how does that fucks it up? Oh my god, I don't understand how it fucks it up, but something is definitely... Oh! Oh no. Okay, look. We're detecting that we're clicking on these things. Okay, so this is 0, this is 1, 2, and 3. Everything's okay. So we can detect that we're clicking on them. That's nice. That's really, really nice. So we have button down, right? And while you're holding down, on being you should be able to move that thing around, right? You should be able to move that thing around. Okay. So let me see. PS selected. So initially it's going to be -1, right? Initially it's going to be -1. And now we need to handle SDL mouse motion, right? Mouse motion. -35. Yeah, it's actually pretty warm today. So at least not -50. At least not -50. So now I should be able to do this thing, right? I get that button motion, right? So this is mouse position, and if we have anything selected, what we're doing, we take PS selected and we assign mouse position to it, right, like that. Cool. So here's the mouse motion if we have anything selected. Cool. What we can do here is now take PS selected and do PS at mouse position. There we go. So once you do that, it gets automatically sort of selected if you actually clicked on anything, right? And now we need a mechanism that deselects this entire stuff. So we're gonna have mouse button up, right? Mouse button up, and if you clicked with the left button, right? If you clicked with the left button, if this thing is equal SDL button left, right? We automatically deselect anything. It's going to be -1. There we go. Make sense? Makes sense. Jiang, did you sleep again? Nice. Welcome. Welcome to our epic Bézier curve club. Yes, that's right. That's what we're doing today. We're trying to implement a Bézier curve rendering. And is it gonna work? Is it gonna work? Let's find out. Boom, 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 boom. Are you ready, chat? It works. Fucking first try this big. Whoa, fuck! I didn't expect it to be so easy. Well, yeah. For some reason I can't select that one, but I can select that one. So 0s1 doesn't really work, but huh? That is so fucking cool. Holy shit! So yeah, Bézier curve. Here's the Bézier curve for you. Why doesn't it show anything? But yeah. Naizu. Bézier curve. It will work. The ancient. Oh, okay. That's pretty cool. So it could be something. So it's a 0 point, right? So it's a 0 point. Maybe that's the problem here. Roger Rules is continuing the gifts up they got from anonymous user. I have no idea what that's supposed to mean. But thank you, if that means that I'm gonna get paid at the end of the month and not gonna starve to death. All right, so let me see. Okay, so we're drawing that. So if it's selected, if it actually gets selected, let me see. If PS selected greater than 0, can we print that? So let me see. PS selected. Cool. If thank you. Greater or equal than 0. Yeah, I actually missed it. Okay, I actually missed it. Yeah, boy. Thank you so much. Thank you, Sami Volis. Yeah, that's actually super cool. So now I can move that, I can move that, and I can move all of that. That's fucking amazing. Holy shit, that's so cool. Yeah. But it would be also even cooler if you could, you know, if we could connect them with lines and stuff like that, and just give more density and stuff. All right, so let's do a committee of what we've done so far. So here what we did, we implemented like a Bézier curve with 4 points. That's actually very interesting. So we, what did I do here? Oh, I made it constant. I thought I actually modified something here. I didn't really modify anything here. Yeah. Allow to modify. Allow the user to modify. The Bézier curve controllers. There we go. I'm gonna push that right into the repo. And check it out. So the source code is available here. And I think the time has come to do a thumbnail for our repo, right? So we're gonna put it something like that. Let's actually find the configuration that looks nice, right? Let's find the configuration that looks nice, something like this. To be fair, you know what would be even cooler? To connect AB and CD with a line. That will be even cooler for the thumbnail, of course. All right, so yeah, we render all of these things. And when we do something like this, it's going to be a render line, right, with a renderer PS0, PS1 with a red color. And another thing we're gonna render is this thing, so that gives us this stuff. Cool. Tiao Cap subscribed with Twitch Prime. Thank you. Thank you so much for Twitch Prime subscription, your first subscription, by the way, and welcome to our epic Bézier Curve Club. Oh shit, I actually fucked it up. Yeah, thank you so much. Okay, so what did I do? Yeah, it has to be 2 0 1 2 3. Yeah, there we go. Yeah, that's what I wanted. Look, it looks exactly like Inkscape shit. Isn't that amazing? Ah, holy fuck, that's cool. It's actually amazing. Yeah, it's like Inkscape. Actual vector editor. Yep. Okay, so I think again, as already mentioned, we have everything. So I need to find like good configuration, and this thing will become the thumbnail for the project, if you know what I mean. So I think that looks good, and I'm gonna do scrot minus s, right? Then I'm gonna go to where it put it. I think that's what we need here. Yeah, there we go. I'm gonna actually move this thing here. And we're gonna call it demo. There we go. And we're gonna put it right into the readme. So let's call it thumbnail actually, since it's a thumbnail. Thumbnail. There we go. Thumbnail. PNG. Okay, so add lines for the handles, right? Add lines for the handles, and then add epic thumbnail. Add epic thumbnail. I'm gonna push that right into the repo. Cool. So yeah, so we can take a look at the source code here. Let us see. And it does have this logo, which is slightly off center, but I mean, who fucking cares? So yeah, Bézier curves. Not bad. So let's actually continue doing things, I suppose. So what else do we need here? I wanted to try to connect these things with why are you already on part 10? Haha. Okay. Yeah. So what I wanted. Yeah. When I am rendering Bézier markers, right, so this is Bézier markers, but we're gonna have a separate function that should render the other stuff. I have a feeling, Shut, that I need a function that returns a point and accepts a p. On top of that, it accepts all of these things, right? It accepts all of these things and returns a p. And essentially what it does, it returns you the sample at the particular Bézier curve. Yeah, so Bézier sample, that's what it is. Right, so essentially it will encapsulate this process because I can now, so I should be able to reuse it in all of the other functions. You know what I mean? So yeah, essentially I'm gonna put it like that. Bézier sample, and here what we're returning here is ABCD. There we go. So this is a Bézier sample, and we don't even need any of this shit anymore. So we're iterating from 0 to 1 with a particular step, basically sampling the Bézier curve, and then we're going to be calling Bézier sample. Bézier sample A, B, C, D, and P. And P is basically the percentage that we're sampling here. So now it should also work really well, hopefully. So, and we abstracted away this entire stuff. It seems to be working. Yeah, that's cool. So the reason why I want you to abstract away is that now I want to have a function render Bézier curve, not the markers. Essentially what I want to do here is now I want to connect the samples with the line so they form like a curve. And to make the curve smooth, I don't know what we can do. We can just basically reduce the step, right? So essentially you have to reduce the step to the point where it looks smooth, and when you zoom in you have to decrease the sample to make it more and more smooth. You know what I mean? So yes, basically you'll have to constantly control that step, the sample step, to make it appear smooth. But yeah, I'm not sure if you can actually make it smooth, but yeah. If you'd start the for loop and render it as the first marker wouldn't be overlapped, oh, sure. Render Bézier curve. Now, SDL renderer, and we're gonna have vec2 A, vec2 B, vec2 C, vec2 D. And we're also going to have this thing and also the color. 32 color. Cool. So how are we going to do all of that now? How are we going to do all of that? Obviously, we're going to have this loop, right? Obviously, we're going to have this loop. Float p 0f less or equal than f. The fuck is going on? Excuse me. Cryptic underscore underscore underscore. I think there's 3 underscores here. Let me actually wait. 1, 2, 3. Yeah, cryptic underscore 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 is gifting 10 tier 1 subs to the Zosian community. Thank you so much for gifting so many subs, and welcome to our epic Bézier curve club. That's right. What we're doing here, we're just doing a Bézier. My favorite kind of dessert, Bézier. Sorry. So you know, I like to drink, you know, long max tea with a piece of Bézier. Okay, so this is what we're doing here. We're just learning how to do Bézier curves. Yeah. So, and how has food to eat for January 2021? Yes, finally. I can eat something instead of just drinking tea. This is amazing. Maybe this month I'm gonna be able to afford a sugar for my tea and finally get fat again. Anyways, so yeah, so what I need to do here is basically sample 2 things, right? So the first sample is going to be, yeah, so let's actually get this thing here. Why did it remove everything? Does this mean you'll let me out of the basement? Yes, sure. You can be free this month. Okay, so this is going to be P, and P plus equals S. So here's the first point, is going to be A, and B is going to be that plus S. So essentially what we can do here, we need to check if P plus S is less or equal than 1. Otherwise, there's no point in continuing doing any of this stuff. Right? So that gives us 2 points. And now, where is my render line? Where is my render line? So here it is. Here it is. I like how simple code becomes when you abstract away everything properly. This is actually amazing, right? So yeah, basically if you want to actually try to smooth it out, you just extract away Bézier sample function that, you know, samples like a single point in the Bézier curve, and it actually becomes super simple. Oh my god, what the hell is going on? Okay, that was really weird. I think I hold control. I think I hold something. I don't know. Something weird happened. Something definitely weird happened. So here's the color, and there we go. So now we're sampling the Bézier curve, and also we connecting all of the points, and hopefully that may look like a proper Bézier curve. Unfortunately, it's going to be too thin for you to see, so I also have to replace render Bézier markers with render Bézier curve. Curve. Yeah, there we go. So is it gonna work now? It doesn't, because I'm Bebega. Yeah. I don't use A, B, C, D, A, B, C, D. I'm literally Pepega, because I already have A, B. Oh my god, so naming is hard. Holy fuck, okay. Okay. That's a really Pepega curve, by the way. It's the most Pepega curve I've ever seen, but it's trying to be less Pepega. Sometimes this kind of shit happens. I'm not sure what's up with that, but it is trying. You see, it is trying. Sort of. It doesn't even connect sometimes here. Yeah. But it's kind of, yeah. With the markers, it looked way better. It definitely looked way better. But yeah, it's kind of fun. Okay, so can we just try to improve that? What if I do something like this, right? Not necessarily like that, right? It always connects now, at least. Yeah. So we can always try to make it smoother by adding more steps, right? So essentially, here's the single step, so we can, you know, do it like that, and now that thing should be even smoother. It's kind of easy, but yeah, we need to have some sort of like anti-aliasing, but yeah, it's pretty interesting. It's pretty interesting, not gonna lie. But overall, yeah, it kind of works. And if you try to replace it with markers, right? With markers, it's gonna have like a huge density. Holy fuck. That looks way better, actually, if you think about it. Look at that. So yeah. Doesn't SDL have some sort of built-in? No. SDL is super Pepega, and this is why I was considering to actually don't use it anymore. Cool to see progress from scratch. Well, you're welcome, I suppose. We haven't finished yet, like we have a couple of hours to do something. And we have a couple of ideas on what we can do. So right now, the whole rendering of Bézier curve happens on CPU actually, right? So all of the decisions and all of the calculations are happening on CPU. I also wanted to explore how would you do that on, let's say, GPU? Because on GPU you have to do the opposite thing, right? Essentially, you start with 4 points, like on CPU you start with 4 points, and you nail it down to a single point, right? You keep reducing it, so here's the process of reducing until that 1 point. In GPU, you have an opposite situation. You have 1 point and you need to answer a question whether that point is on the curve or not. You see what I mean? You see what I mean? So you, on the GPU, in a shader, in a fragment shader, you will have to work out in an opposite direction. So first you have a point, you need to answer whether that point lies on the line ABC, BCD, and then whether ABC lies on these lines, and so on and so forth, and you have to sort of like unravel it. And you have to do that for each individual pixel. You'll have to do that for each individual pixel. That sounds so inefficient, yes, and that's probably maybe why on GPU shaders you wouldn't do that many points for the Bézier curve, right? Maybe you're gonna end up with like 4 of them or 3 of them, so you don't have to do that many computations. You're gonna use mesh shaders? I'll think about that. Yeah, I'll definitely think about that. We'll see. So this is one of the things I want you to explore with this project. Another thing, we could try to implement Bézier sample that works with arbitrary amount of points. But it's kind of difficult because you need intermediate data structures. I think you need intermediate data structures to achieve that, but I'm not 100% sure. Okay. Because it feels like you can do something about that. It feels like you can, but I'm not sure. Okay, so here's the thing that we want to do. So I'm gonna put to-dos here. To do, make Bézier sample to work with arbitrary amount of points, right? So this is one thing we want to do. Another thing, explore how to render Bézier curves on GPU using fragment shaders, not mesh shaders, mind you, fragment shaders. To be fair, maybe this kind of stuff shouldn't be done on the fragment shaders. You know what I mean? Maybe this kind of stuff has to be done in the vertex shaders. And on the vertex shaders should be pretty straightforward, I think. Yeah. On the vertex shader is actually pretty straightforward, if you think about it. But you need to have a buffer of these vertices. The buffer of these vertices that is shared between all of the vertex shaders, and essentially you iterate through the indices, and for each vertex you're just doing this process, and then you have a list of vertices generated on the GPU. A list of vertices generated on the GPU, and then you pass it to shader, and so on and so forth. You know what I mean? You know what I mean? Yeah, it's kind of interesting. I think like it's easier to do on a vertex shader than on a fragment shader. On the fragment shader, it looks like very inefficient and probably very error prone. But at the end of the day, you're gonna end up with a still sampled result where you have just these segments. Yeah. Anyways, so does SDL support shaders? By the way, hello Snaffly. It does not support shaders because it abstracts away shaders from you. Yeah. Okay, and another thing I wanted to do, I wanted to be able to switch between the mode where I could, yeah, to do switch between markers and lines at runtime. So this is basically the to-dos that I want to do here, and let's actually commit everything we have so far. Okay. Implement render Bézier curve. Implement render Bézier curve. Yeah, and let's push that right into the repo. Again, you can find all of the source code here if you're interested, right? So here's the project. We implemented it in pretty much 2.5 hours. I already have it opened here. So, and yeah. Okay. I'm a little bit tired. Does anyone have any questions, by the way? SDL-GFX apparently has support for AA and even Bézier, if it's worth noting. I used GFX, it's extremely Pepega. The reason if it's so Pepega is that it built on top of SDL, and SDL by itself is very limiting. There's not that much you can do with SDL, because it's trying to generalize over a huge range of diverse drivers, and also it's very old. So I think at some point I want to like stop using SDL completely and switch to something like RayLib, right? RayLib actually sounds very interesting. It's more modern, it can do more things, it can even support 3D. SDL cannot do 3D unless you use OpenGL directly or something like that. So Here's the architecture, by the way. So it's built on top of OpenGL, and it wraps completely OpenGL. It has something RLGL. I don't know what RLGL is, but you can put your shaders into it and do some stuff. Sounds nice. Right, why not Vulkan? Rayleap is actually higher level than Vulkan, right? It's basically on the same level as SDL, right? Alright, so let's try to do something, chat. And here's by the way, me explaining how you render Bézier curves at the beginning of the stream. It's pretty cool. So let's actually have some sort of like a boolean. Int markers 1, right? Does Rayleaf support? Yes, it does support macOS. So you can check out their website, by the way. For what kind of platforms do they support? They support Windows, Linux, macOS, FreeBSD, Raspberry Pi, I suppose, Raspberry Pi Desktop, Android, HTML5. So these are all of the platforms that support that. And there's also bindings for C#, Go, Python, Ruby. Rust bindings, I looked into Rust bindings today, and they seem to be very incomplete. So it's kind of meh. So yeah, there's only support for the major 3 platforms, right? There's no support for Web, Android, or Raspberry Pi or anything like that. It's not like I need it, but it would be nice to have. Our LJL is not even supported on Windows, so it's kind of like not really finished. Classical Rust library. Classical Rust library. Okay, so what I want to have here is if markers is set, right? If markers are set, I'm going to use render Bézier markers, right? Yep. And otherwise, I'm going to do render Bézier curve. I'm going to as well actually copy paste this entire thing, right? And just use curve because it's pretty much the same thing. And I need something that will toggle all of this stuff. So we have mouse button, blah blah blah. So case SDL key down, right? Here's what we have here. And we're gonna switch upon event key key sim, right? So this is the symbol, and we're gonna have case SDLK. So which one do we want to have? Let's put something like F1, I don't know, and it's gonna toggle markers essentially, right? So it's gonna be markers equal not markers, and I think that should be okay. So boom, boom, boom. So here are the markers. F1. Now we don't have any markers. F1. Now we have markers, and we probably want to change the step because the step is too goddamn huge. Okay. Define Bézier sample step is going to be 0.5, and we're going to reuse that sample step for both of these branches here. Bézier sample step. Cool. Let's do something like this. There we go. And then I can switch between the modes, just so I want to see these things, and that's actually pretty cool. That's actually pretty cool. F2, F3, increase, decrease step. Sure, let's actually implement that. Let's actually implement that. So we can, I don't know, we can have some sort of a slider for this kind of stuff. Okay, so this is what we're gonna have here, and it's gonna be float, right? Bézier sample. So it's gonna become a variable, right? So that you can modify at runtime. And how are we gonna modify it? So that's the good question. Maybe we're gonna modify it with a mouse wheel. SDL mouse wheel. SDL mouse wheel. Case SDL mouse wheel. Is it mouse wheel event? I think it's just a mouse wheel event. You forgot equals in a variable. I have no idea what you're talking about, and if this is something that can be caught by a compiler, I don't really care. Okay, so mouse wheel, and if event wheel y greater than 0, right? If it's greater than 0, we're gonna be incrementing the Bézier sample step. It's gonna be like that. Plus 0, 0, like maybe 1, right? And we need to be a little bit careful, so we're gonna do f minimum between 1, because we don't want the step to become greater than 1, right? And the same thing is gonna go for the negative part. I mean, it has to be the negative, so it's gonna be if event wheel y less than 0. So the negative is gonna be minus, and we're gonna do max between that and 0. So we don't want it to be, so we want it to be clamp between these two things. So maybe I can even abstract that away by essentially using clamp instead of min and max, and basically add this step multiplied by the sign of this thing. But do I really want to do that? I don't really want to do that, but we can try to do that. Why not? At some point, who knows? It doesn't even compile. Would you look at that? You see, I forgot equals here, and as I said, if it's something that can be caught by the compiler, I don't even care. Right, so why should I stop my trail of thoughts to fix something that can be caught by the compiler later when I finish my trail of thoughts? You see, like, this is the reason why we're using statically compiled languages, right? This is the reason, because they improve their productivity. You can write incorrect code without interrupting your thoughts, and the compiler later, keyword, later will tell you where to fix all of that, not when you already run this program and deploy to a production. No, before you even try to run it. That's the point. That's why this language is better than, for example, JavaScript or Python, right? Languages for serious software development are statically typed compiled languages, period. Cool. So and now if I try to, yeah, as you can see, I use my my wheel, and I can now increase the density of these things, and that's pretty cool. I think that's pretty cool. And then I can also switch between these modes, and yeah, that's actually pretty cool. I especially like how it looks like. You just scroll and it just becomes less dense and then more dense. So that's kind of cool. Oh, that's actually super fucking. Oh shit! It actually it's stuck. It has so many points. I have to execute it. Oh shit! It's still going. Holy fuck! Wait. Grab Bézier. Kill all Bézier. Oh shit! Kill -9. Okay. Too many points. So you have to be very... maybe I know what the fuck is going on. Maybe I fucking know what the fuck is going on, because if it becomes 0... If it becomes 0, it will never finish execute. Yeah, because if step is 0, it will stay on the same point, like forever. That's basically what happened. I'm a professional software developer, by the way. Okay, so let's clamp it appropriately. First of all, I want to have clamp like... First of all, it's going to be 99, and this one is going to be 001. Right, it's never going to be 0, so that's quite important. It's never going to be 0. Boom, and yeah. And I think it's going to stop at some point. Oh, it's actually, you have to go in the opposite direction to decrease it to 0. So we're decreasing it, and it never becomes 0. Look at that smooth line. Holy fuck. Alright. Isn't that what we wanted? Do we even need that thing? Like it? Yeah, we'll just leave it like that. I think this is amazing. To be fair, I think all of the handling like should be drawn on top of these things. Yeah, so we're gonna put it like this. And we're gonna change the drawing order. Yeah, it does look like a French fry, to be fair. It kind of does. Alright, so looks cool, and let's make it almost 0, and it now looks okay. Holy shit, we need to update our thumbnail, because I think we have a better thumbnail now. Yeah. Oh shit, yes, this is a better thumbnail. I like it way better. The time has come. Cool. Pum, 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 pum. Oh yeah, it's kind of dumb. I think GitHub is not gonna automatically update it. I'm gonna show what's gonna happen. So if I check, this is the thumbnail. Oh shit, it has this stupid border. Okay. I should stop using scrots because it screws up all of my screenshots with this like stupid thingy. Alright. How about uniform steps instead of fixed steps in the p-value? Probably. Krita. Fita. Sorry. So here's the brush, and yes, this is what I have to do. Yep, I'm a professional artist. Yeah, I know what I'm doing. So I'm gonna save it back. There we go. And now we don't have that stupid frame anymore. Isn't that amazing? Okay, and I'm gonna rename this to thumbnail. 2021, and it's gonna be thumbnail. Look, and now I can try to commit that, right? So first I'm gonna commit this. So what did we do here? More controls over more controls, I think, and then we're gonna update the thumbnail. Update thumbnail. So I'm gonna show you the protagonist of the GitHub if we're lucky enough. Not sure if it's gonna work, but we'll try. We'll try. Oh yeah, there we go. I think. Did it work? Yeah, we pushed everything correctly, and yeah, there we go. The thumbnail didn't change. Have you noticed that? The thumbnail here is absolutely fucking different. Wait, is it? Am I Pepega? Yeah, okay. Yeah, this is the Pepeganus of GitHub, by the way. This is the Pepeganus of GitHub. Or maybe not GitHub, but specifically of how they cache things. So update thumbnail. All right. Okay, I tried at least. GitHub is like really strange when it comes to updating. Yeah, it's cached. It's so fucking dumb. Holy fuck. Like, I struggle with it so many times. Maybe browser cache. Image is okay for you. Okay. So, what if I try to do something like this? Okay, I'm gonna control F5 maybe. Yeah. All right, so we're gonna assume that maybe it will update, will be updated later. Let's continue. Whatever. So what's the next thing that I want you to explore? Control Shift R. Make some Bézier sample to work with arbitrary amount of points. So that's what we need to do. Let me think how we can do all of that. So we need some sort of like a Bézier sample that accepts, you know, several of them, access, right? And also float p, but we also need the size, right? So it's going to be size t, access size, right? So, and essentially it's going to be like this function. So this function can be called Bézier sample, Bézier for sample, and this can be Bézier n, like this, right? So that's essentially what we want to do here. But the question is, how can we even achieve all of that? Right. So n kinda defines how many of these phases we have to do. So the first phase, if you look at this, right, the first phase is that, the second phase is that, and the last phase is that. You can kind of split it into like these virtual phases. Phase 1, then phase 2, then phase 3, right? So, and maybe we can reuse the same array constantly. So essentially we could implement something like, let me put it this way, while n is greater than 1, right? So while n is greater than 1, we're going to be constantly collapsing those things together, I think. Yeah, so we have points A, B, C, D. We need to interpolate between A and B, and we can store it into A, right? So basically, access I could be viewed as lerp v2 from access I plus 1, right? And of course it's going to be p, and we have to keep repeating this entire thing until n becomes 1 and we have only 1 point, right? And then we can just return access 0, which is that 1 point. This is actually a pretty cool approach, but the problem with this approach is that it consumes the points. It consumes the points, so you lose all of the information about these points. So you have to sample them by constantly copying them. You see what I mean? You have to sample them by constantly copying them, which is not that particularly convenient. So, and the question is, how can we do all of that more conveniently, like maybe without additional memory or without anything else? Does anyone have any idea? Or copying the array is the only thing we can have? It's enough to copy them only once. What do you mean? It's enough to copy them only once. You have to copy them every time you're about to call this function. What do you mean once? No, you have to copy it every time you have to call this function, because this function destroys the array. Excuse me? That's kind of the point. That's kind of the problem. And that's what I'm talking about. Create a copy of the points and use iterative function, not recursive. Let's make a cup of tea. Does anyone have any questions, maybe, about what we're doing or anything? While I'm making a cup of tea, because I definitely need a cup of tea here. How big is your storage of tea? It's not that big, actually. It's just this bag, but I bought it today, right? So I had a similar bag, and it lasts me for like a week or so. So yeah, once per week I just buy such a bag, and it's just, yeah. I don't really drink that much. Don't really drink that much. Does anyone have any questions? So while I'm making a cup of tea. Does anyone have any questions? Or maybe somebody has any ideas on how to not copy array here, because that's kind of the problem. Right, so where do you live? In Russia? Why C and not C++ or C#? Why not? I'm disappointed. I'm really disappointed in chat. Okay, so since nobody has any better ideas, we're going to implement the version of the Bézier sample that does in fact consume the array, and we'll have to copy. Pass to arrays. How is that different from copying the array? Okay, so essentially you pass in a piece of memory to which you're copied yourself. Cool. All right. So what we're gonna do here? So we're starting with iterating by pairs. Yeah. So this is what we'll have to do here. So size t0, right? Size t0. I less than n minus 1, I suppose. So it's going to be like this, right? And as I already said, we're going to do I lerp v2 access I plus 1 at a particular interpolation. So this is how we interpolate all of that, and this is basically the Bézier n sample. Bézier n sample. So, and it would be kind of interesting to try to implement Bézier 4 in terms of Bézier n sample. All right, let's see if it compiles or not. Let's see if it compiles. So Bézier 4 sample, this is what we expect here, and Bézier 4, 4. Cool. So, and let's see if it still works. It does still work, so we didn't break anything. So now let's go to here and try to implement it in terms of Bézier n. So how are we going to do that? We'll need to create a local array of access. So it's going to be something like this, right? A, B, C, D. And then we're going to just return Bézier, Bézier n access for P. And we can remove all of that because it will automatically do all of these phases for us. Yeah, so now it's as simple as that. It's as simple as that. Does it still work? Oh shit, it doesn't work. Fuck. Yes, I know what happened. I forgot to decrement the n. Please forgive me. I forgot to decrement the n. Holy fuck. I just forgot to. You forget to decrement the n, and it all goes to shit. Okay, so this is what I forgot. Of course, like. I'm sorry. So we could try to do something like 4, whatever. All right. So let's see. And now, fuck. Wait. Oh, I thought something wrong happened, but it works. It still works. Look at that chat. Isn't that amazing? I think it's fucking amazing, mate. Oh yeah, Shazwak, what's up Shazwaku-sama? Look at what we've done. We've implemented Bézier curves. You know how in vector editors you can do these curves and shit? We implemented that. Isn't that amazing? Isn't that amazing? I think it's goddamn fucking amazing, mate. I'm sorry. Okay. So now maybe we want to try to get rid of the Bézier 4 completely. How about that? Does it sound like something interesting? So, but to do all of that, we'll have to constantly copy this array, right? We'll have to constantly copy this array. So let's introduce access PS capacity. Yeah, and every time we need to do that, we'll have to literally mem copy and just pass it there and suffer. All right. So this is what I'm going to do. I'm going to remove the Bézier 4 and I'm going to update render Bézier markers with essentially just vec2 axis, the amount of those axes, and I guess that's it, right? That's literally it. And here, yeah, so now we're working with arbitrary amount of points, which is pretty good, not gonna lie. Okay, so this is Bézier 4, we have to use Bézier n, and it's gonna be access n. Cool. So this is access n, and this is the same situation. Oh shit. Render Bézier curve actually needs to do that twice for the current and then... Holy fuck! Oh my god! You need to constantly copy all of these. Holy shit! Yeah, because every time you do Bézier sample, it actually consumes this entire array. It consumes this entire array, so you cannot use it anymore, so you have to constantly copy it. So you do need to pass to... So it's even worse than I expected. It's even worse than that. It's even worse than that. That is what it is, and it isn't what it is in chat. And I think my tea is ready. So yeah, I'm gonna go to the kitchen real quick. You know, put some hot water in my tea, and I'm gonna get back. And of course, if you leave during that time, you're permabanned from the channel. That's what's gonna happen. Okay, how's it going, everyone? How's it going? Well, Kolumbetka is banned. Everyone is banned. The whole chat is banned. That's what I can say. Everyone is banned. Okay, so essentially what we need to accept here, I suppose, is additional buffer to which we're going to constantly copy this entire thing, right? So it's going to be something like this. It's kind of interesting. So we can accept it like that. So it's going to be PS and axis and also N. So we have two buffers with the same size. And maybe we can even do that on the level of Bézier n curve, right? So you accept the original points and additional like intermediate buffer that you can that the function is gonna use, right? And what we're gonna do here, we're gonna do mem copy So the destination is going to be axis, the source is going to be PS, and how many things we want to copy? We want to copy vec2 multiplied by n, right? Before trying to transform the axis, we just copy there, and there you go. So it's like an intermediate buffer that this function needs. It's kind of, you know, similar to some of the mathematical functions that do, you know, solve system of equations. They usually require additional memory that you have to allocate for them. Okay, so here is this thing. So now if you want to call it, you will have to call it like this. So here's the point, here's the axis. And similarly here, we have vec2 ps, like that, and you'll have to call them similarly. So it's going to be ps axis and n. And this one is going to be ps axis n, but p is going to be plus s because it's an additional step. And I think that's going to be okay. That's going to be okay. Do we have anything else here? All right. So once you try to render it, you have to put ps axis and n is essentially ps count, right? It's a ps count. So what we're trying to achieve here, chat, is an ability to draw any order Bézier curves with any amount of points. That's what we're trying to do here. So, and the problem is that the more points you're going to have, the slower the program is going to become, because it's going to have more and more phases to compute things. So ps count. It looks like this function can be implemented in a recursive way, and then you won't need to modify array values. But I haven't tried yet. Yeah, I can see that you haven't tried yet. All right, so let's actually remove this thing. Have you programmed in C, by the way? Have you programmed in C? Because I think you haven't programmed in C either. So what else do we have here? So when we're clicking on something, okay, this is actually quite important. I think we should be allowing to add more and more points. But if you're clicking on this thing, so here's the mouse, and like this, you try to select that, and if ps selected is less than 0, then we're just adding a new point here. That's how it's going to work. If we're not, we're gonna do it like that. Okay. Yep. We work with any amount of points. So this is like any degree curve. This is literally any degree curve, which at some point doesn't make much sense, but I think it's pretty cool. I don't really understand why this doesn't work, but with this it does work. And then at some point you can even add that. And this is actually a multiple degree Bézier curve. So it's actually pretty cool. You can add more and more. And modifying any of them actually modifies it in a particular way. And it feels like there's no any point in adding more than 2. You know what I mean? Kind of doesn't make any sense. Oh, I know why. Because I actually don't render anything unless we have something here. It's kind of an interesting limitation. I think it's kind of an interesting limitation. What if we get rid of this limitation? Oh well, that's interesting. So maybe we're gonna try to do something like, if you have at least one. What if you have at least one? Okay, that's cool. So a single line is the first degree Bézier curve. 3 of them. Nice. Another one. There we go. Another one. There we go. Amazing. That's pretty cool. So when you start to have like a lot of this, like it's kind of difficult to keep track of them. So what I want to do, I want to actually connect the controllers, right? So yeah, I want to connect the controllers so we can actually see them. So we render the markers, and on top of that, we're also going to render a line. It would make sense if I is less than ps count -1, right? So we're only going to do that. So we're rendering the line is going to be renderer psi +1. So it's going to be red color. Okay, so you have something like this, and you cannot see the line yet, but between the red lines there's like a red markers, there's this red line, right? So the reason why I have it here, so we can actually see how it goes. And once you start to have a lot of these things, right, you can at least see like how they affect the final Bézier curve. So I think it's kind of actually useful to have them like that, right? Because at some point, that's actually very nice. I like that. And you can have like a spiral. Holy shit, that's a thumbnail right there. Yeah, this is a thumbnail right there. And by the way, I can actually increase the density of these things and also decrease the density of these things with the mouse wheel. So it's actually pretty cool. Holy shit. And like the thing is that it's such a simple math. Holy shit. It's a very simple math, and you wouldn't expect such a simple math to produce such an interesting results. Well, it's kind of usual with math, I would say. It's kind of usual with math. Okay. So this is a new thumbnail. All right. Okay. That's pretty epic, not gonna lie. That's a pretty epic. So here's another one. For fuck's sake. All right, so we implemented like arbitrary degree Bézier curves. So the only thing that is left is to explore how to do this kind of shit on GPU, right? So because we haven't explored how to do that on GPU, and GPU is actually kind of interesting. So I'm still kind of curious, how would you do that in a fragment shader, right? Because again, in a fragment shader, what you have to do is the same thing as in the Bézier N, right? Bézier N, like this, but in opposite order. So here we start with endpoints, right? We start with endpoints and end with 1, but in a fragment shader, it's opposite. You start with 1 point, and knowing the initial points, can you tell if that point is on the Bézier curve or not? So you have to unwind these equations, right? You have to start unwinding them somehow. But to be fair, and also, like, you not only have initial points to figure out, you also need to figure out P, at which P, right? Is it, if it's on the Bézier curve, at which P it is on the Bézier curve? This problem sounds like magnitudes harder, actually. So, like, trying to figure it out in the reverse is just magnitudes harder. And I'm not even sure if it's gonna be, you know, feasible to do on a fragment shader. But maybe it is. Maybe there is like a very efficient way of doing that. Not the magnitudes. Oh, I'm sorry. I triggered your PTSD. I didn't mean to. Didn't mean to trigger your PTSD. I'm sorry. Okay. So here's the thing. Okay. So I'm gonna. So here's the new thumbnail, and I'm gonna remove that. Okay. So this is a thumbnail, 2021. Thumbnail. Okay, let's update the thumbnail. Explore how to render Bézier curves. And did I? Yeah, I forgot to remove the end. I usually clear cache by opening DevTools and clicking. Yeah, I could do that. I'm just too lazy. I'm sorry. Maybe the curves work with arbitrary amount of points. We did exactly that. Now it uses arbitrary amount of points, which is absolutely nice. I also want to do a couple of cleans up here. So essentially, if it's not and PS count is less than PS capacity, so we don't want to overflow the capacity, so we're gonna do something like this. Yep. Okay, I guess that's cool. So let's see. It's actually getting slower. It's dropping frames. It's really dropping frames. But you can do things with it. You still can do things with it. Holy shit, it's slow. Oh yeah, it's actually it's really smooth and stuff. But we can reduce the amount of like samples and it becomes faster. Yeah, reducing the amount of samples actually helps to make it a little bit faster. Yeah, it's pretty cool. Not gonna lie, it's pretty cool. Bézier curves. How about that? Some of the edges are flattened. Yeah, I guess. Just a second, I think it's good to work it a little bit. It produces really strange sounds sometimes. All right, so let's do a committee. Are we ready? Did I remove to do? I forgot if I removed to do. Yeah, okay. Make Bézier rendering work with arbitrary amount of initial points. So let's push that right into the repo. Okay. How can you do that on GPU with the fragment shader? All right. Let's go back to the drawing board and let's try to figure out. Because fragment shaders are kind of complicated, right? Fragment shaders are kind of complicated. You are allowed to make a program that is going to be executed. In parallel for each individual pixel. Right, here's your screen. Right, and you're writing a program for a single pixel. Right, for a single pixel. Right, and it's going to be in parallel executed for all of them. Because of that, you cannot look into the neighbor pixels or anything like that. So the only thing we need to do, we need to have the array of initial points, like PS, available to each individual pixel, right? So available to this one, and this one. And knowing the coordinates of that pixel, can we answer the question whether it is a part of the Bézier curve for these initial points? Can we answer that? So this is basically the question. Can we answer that? So yeah, we can probably create some sort of a vertex buffer so we can share all of the vertices here. But it's going to be extremely painful. So let's actually take a look at how exactly you calculate the Bézier curve. Right, so there is a pretty POG visualization that I showed at the beginning of the stream. So we have this P, and you have initial points, and you interpolate them until you get only one point, and there you go, here's your Bézier curve. So essentially you have a point, you need to figure out whether it lies on this line. But the problem is that depending on the P, it will it will lie on different lines. It will lie on different lines. So then once you know this line, you need to figure out these two lines, and then you need to figure out these two lines and end up with this exact stuff. So one way to do that is again re-implement this thing where in the shader you basically iterate through all of the p's and see if you end up close enough to the original point. Yeah, essentially in each shader, knowing this array, you repeat this algorithm and just check if you're close enough to the point of the fragment. You see what I mean? If you end up close enough with the point of the fragment at any particular p, and then you color it, there's an inverse lerp. I don't think it's gonna help. I don't know. It's not that. All right. So you have to iterate every p. I suppose you're also gonna have like a sampling. You're also gonna have sampling. And you can end up with things that are close enough to the original samples and whatnot. But yeah, so coming up with the proper solution that works like with fragment shaders probably involves really complicated math. Not really complicated, but more complicated than what we already have. Binary search of P. Probably. So yeah, I don't think if I will be able to easily do that. There's an algorithm to find the closest point to a Bézier. I see. So that means people already try to solve that. All right. Anyway. Maybe I'm gonna try to do that later. Maybe I'll try to think about that a little bit later. I think I'm gonna finish the stream here, right? Because I kind of explore everything I wanted, and exploring even further, they're basically trying to do a reversed Bézier curve is actually out of my abilities right now. I need to think about that off stream, and maybe research that off stream. So yeah. So I think I'm gonna finish the stream today. Do I need to commit anything? I think I don't need to commit anything. All right, so we can find the source code for everything we did today here. So if you're interested, and it is time for me to go. It is time for me to go. That's actually pretty cool. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you tomorrow. Tomorrow we're gonna be doing a game development. Right, so tomorrow we're starting a weekend streams, and on weekend we're working on our game in C++, so check it out. Check out our schedule page for more information on different projects we're working on, and also check out our VODs channel, where we upload all of the recordings of our streams. This stream is going to be there, but tomorrow, so subscribe to that channel to get notified. And also check out our Discord server for offline discussion with the community. So yeah, thanks everyone for watching, and I see you all tomorrow. Love you all.